Good morning. I'm Debra Goldfarb. I'm the Director of HPC Products and Strategy at AWS. Let me start by thanking our ARM colleagues for inviting me to share some exciting news about our new Graviton2 processors. So let's dive in. But first, I'd like to provide some context about where Graviton2 fits in our overall compute portfolio platform. AWS has the broadest and deepest compute platform choice. We have families of instances designed for just about any workload, ranging from general purpose to raw CPU cycles, memory intensive per CPU. We have dense storage. We have powerful GPUs and those that are optimized for graphics intensive workloads. Each of those instance families can be further customized, including with choice of processor, type of storage, ultra high-speed networking, and even bare metal options. When you add in additional options such as Elastic Block Store and Amazon Elastic Inference, we have more than 275 instance types for virtually every workload and business need. Our goal is to have, again, the broadest and deepest compute platform choice to support the existing and emerging sets of workloads and business requirements going forward. Let's take a look specifically at Graviton processors. This is the AWS Graviton processor is a custom silicon design with 64-bit ARM Neoverse N1 cores. With our vast experience in running cloud-native workloads at scale, we've been able to target specific optimizations in the chip itself. This is very, very important. Graviton is literally designed for the cloud, and by using all the learnings we've experienced from use cases and workloads, we've been able to really hone in on those targeted optimizations, which make this an extremely performant processor. And by building our own custom processors, we can rapidly innovate on behalf of our customers. And by doing this, we provide excellent performance and very significant cost savings for our customers. So our focus is making sure that we take the learnings from the experience of our customers and make sure that we drive those learnings back into our processor optimizations to really provide that exceptional performance and price performance for our customers. So let's now take a look at Graviton2 versus AWS Graviton, the first generation. So for all of you who love to look at or hold the processor in your hands, this is an actual photo of the new AWS Graviton2 processor. And as I mentioned, it uses 64-bit ARM Neoverse cores. It has roughly 30 billion transistors. This is an extremely performant processor, and it is the first 7-nanometer processor deployed at AWS. But what does that actually all mean? So this is all in comparison to the first generation of Graviton. Graviton2 has 7 times the performance, 4 times the compute cores, 5 times faster memory, and twice the amount of total caching. It is an exceptionally performant processor. So let's take a look at how we're utilizing these processors specifically for our instances. So we're able to offer the AWS Graviton2 processor in 3 new instance types. These Graviton2-based instances offer up to 40% better price performance over comparable current generation of x86-based instances. The M6G is specifically oriented towards general purpose workloads like the rest of the M series of instances. We also offer the C6G for compute intensive and the R6G for memory intensive, and those are really going to be optimized for those HPC and AI kinds of workloads. All of these are available now and including local NVMe-based storage, SSD storage options, and every instance type also has bare metal options. So what's important is also we have a free trial for our burstable general purpose workloads called the T4G. But the portfolio is really rich right now, and everything is available, again, around these general purpose, compute optimized and memory optimized, as well as bare metal options. So let's take a look at what makes up the specifics of the Graviton2 instance. First, we have the Graviton2 processor itself, which is 7nm custom silicon and offers just absolutely exceptional performance. However, Graviton2 is not the first or the only piece of custom silicon powering Amazon EC2. We have the Nitro security chip, which is integrated directly into the motherboard, and it protects both all of the hardware resources, and it monitors those hardware resources as well. Additionally, we have the Nitro card, and the Nitro card itself unloads many of the traditional software needs of the hypervisor into bespoke hardware. And what this does is it allows for much better performance and a much lighter footprint overall in the infrastructure. The Nitro card handles interfacing with devices such as Amazon Elastic Block Store or the Elastic Network Adapter, and it also really focuses on providing additional monitoring and security for all of those interfaces. So this is in addition to the Nitro security chip. Last, but certainly not least, because of the Nitro security chip and the Nitro card, the Nitro hypervisor itself is very lightweight, handling memory and CPU allocation with bare metal-like performance. These purpose-built and modular building blocks give Graviton2-based instances absolutely tremendous performance. So what does that all mean for our customers? Graviton2 powered instances can lower your total cost of ownership significantly. It has the highest performance within their instance family, along with 20% lower cost versus the same size comparable instances, particularly against CPUs. And again, this leads up to 40% better price performance, again, compared to x86-based instances. This is the best price performance processor within its instance family and can lead to real cost savings and performance for our customers. So what about the ecosystem? So when everyone talks about ARM, they want to make sure that the applications, the infrastructure, the ecosystem is there to support. And what we're finding is that we are building we have tremendous momentum in the ecosystem supporting Graviton software. So on the OS side, we have a whole range of options, including popular distributions out of the box, AWS, Amazon Linux 2, we have Ubuntu, we have SUSE, we have Red Hat, Enterprise Linux, we have Debian, Fedora, FreeBSD, NetBSD. We have a very rich set of operating system options. In addition to that, getting more granular, we have significant container support from Docker and Docker Enterprise Engine. We have Amazon Elastic Container Service. We have Amazon Elastic Container Registry, or Amazon ECR, as well as some emerging container technologies such as Firecracker and BottleRocket. And last but not least, we're building a very rich set of tools and software and support. We have supporting Amazon Marketplace, the Systems Manager, CloudWatch, AWS Cloud9, Batch, Code Commit, Code Pipeline. And as you can see, all up, the Graviton software ecosystem has tremendous momentum. And we believe this is a critical piece to making sure our customers have the right kinds of capabilities as they transition over to this technology. So let's do a little bit of a deep dive into the processor itself. Let's start with the cores. These, as I said, are built on Neoverse N1 cores, and it is ARM version 8.2 compliant. As you can imagine, we worked very closely with our ARM partners on the creation of N1. An example of what kind of performance and kind of partnership we've had is specifically looking at the caching on the processor. We have a large 64 kilobyte L1 cache along with a 1 megabyte L2. That's 2 times more for each virtual CPU, which fits the demanding cloud-native applications. A coherent instruction cache helps here as well and is actually uncommon for ARM-based processors, but we felt it was critical for this processor. The Graviton2 is purpose-designed for cloud-based servers. It has low syscall overhead with 4 wide front-end and 8 wide dispatch per issue. It has dual SIMD units, and it has data types to accelerate machine learning inference with int 8 and floating point 16. Every virtual CPU is a physical core, and there is no simultaneous multi-threading. And the reason we did this is because it leads to more isolation where cores don't share resources except in the memory system. This also allows for smaller instance sizes, such as the M6G medium instance. So let's take a look now at the interconnect. Graviton2 uses a mesh interconnect between its 64 cores. This gives us approximately 2 terabytes per second of bisection bandwidth, and it has a 32 megabyte last level cache with private caches over 100 megabytes of user accessible caches. Because of the mesh, there is no NUMA with Graviton2. Each core sees the same path to memory and other cores. This alone can increase performance on non-NUMA optimized applications significantly. Last but not least, Graviton2 also supports 4th generation PCIe Gen 4 with power, which powers the local NVMe SSD storage, and it's available in the D variants M6GD, C6GD, and R6GD. A great source of up-to-date information on all things Graviton2 is our Getting Started guide on github.com. It's been assembled by our Graviton team and is there to provide guidance for running workloads on Graviton2. It includes tips and tricks for maximizing performance across various languages and libraries. And in general, using the latest versions of operating systems, compilers, and runtimes, it will automatically include the latest optimizations for ARM64 and is highly recommended for anyone who is interested in exploring and getting started. So in summary, Amazon EC2, M6G, C6G, R6G, and the T4G instances powered by AWS Graviton2 processors provide up to 40% higher price performance over comparable x86-based instances. This is a performant processor, and we're extremely excited about it. Graviton2 powered instances power a broad spectrum of workloads, application servers, open source databases, in-memory caches, microservices, gaming servers, EDA, HPC, and video encoding. This is a processor that spans the wide range of existing and future workloads and will provide tremendous benefit to our customers. Most Linux and open source based applications can easily run on multiple processor architectures and are well suited for the new instance types. These instances are supported by popular Linux distributions and an extensive ecosystem of independent software vendors, growing every day. And finally, the M6G, the C6G, the R6G, and the T4G instances are available now, along with local NVMe support and bare metal variants. I want to thank our ARM colleagues, our partners, for the opportunity to share information about our AWS Graviton2 processors. Thank you and have a wonderful day.